So hello, everybody. I assume we're live. This is Simon Geerlofs with Pacific Northwest National Laboratory. Really excited to be here today. Thanks to Jason and the whole POET crew for inviting us to present on ocean-based climate solutions. So we have a really great panel today. I think we have about an hour and 15 minutes, and we're going to do a short panel format here. Each of our panelists will present for about 10 minutes, and then we're hoping to have a good discussion with you all. And this panel is really talking about a broad set of opportunities to revision how we use the ocean as part of the climate solution space. And I think most of us who have worked in the ocean for many years tend to see the ocean, when it's mentioned in terms of climate change at all, as a zone of impact. So what's going to happen to our coasts, what will happen to our communities, how do we adapt to climate change? And I think more and more, we're seeing more of a consensus in the policy community and the science community, looking more towards the ocean as a place for solutions. So how do we actually use the ocean to close the emission gap that we need to achieve to meet our ambitious targets for decarbonizing the economy by 2035 and 2050? So many of you work in the marine energy field. So obviously, I think we're used to thinking about these things. How do we use the ocean as a source of renewable power to decarbonize our electrical grid? But a more holistic approach could reveal new opportunities, new ways of thinking about marine energy, but also ways of thinking about the ocean as an underutilized asset and a tool to address climate. So lots of recent reports in this space, and Mike Conathan will give us a quick rundown in the policy world, but one of the leading reports discussing these opportunities was authored through the high-level panel for sustainable ocean economy, the report on the ocean as a climate asset. And this report looked at 5 major strategies for using the ocean to close the emission gap, including ocean-based renewables, ocean-based transportation decarbonization, coastal and marine ecosystems, fisheries and aquaculture, carbon storage. And the report came up with a number that said if we use the ocean and we do it all well at scale and at speed, we could potentially close up to 21% of the emission gap by 2050. So very large potential opportunity here. Looking at it another way, if you start looking across the reports and the policy papers in this field, 4 major sectors start to emerge. One is decarbonizing everything we do in the ocean, focusing first on maritime decarbonization. The second being thinking about the ocean as a source of renewable power, so marine energy plus offshore wind plus floating solar. Third, thinking about a decarbonized seafood sector. And fourth, thinking about how we protect our ecosystems, which are already absorbing so much of the carbon we emit, ensuring they continue to provide those services even in a changing climate, and looking more actively towards technologies and techniques to directly utilize the ocean to remove and store carbon dioxide. Those opportunities are underlain by a set of values, which are sort of typical values we see in the blue economy. How do we realize opportunities and capture those opportunities while also working to have an equitable energy transition? How do we ensure that we're protecting our coastal ecosystems? And how are we looking for opportunities to grow our economy and make infrastructure investments that, again, promote equity and justice in our communities? So our panel today is going to touch on many of those opportunities, as well as discuss some of the underlying values I presented at the end. And I'm really excited. We're gonna just kind of go through each panelist. I would like to just have our discussion at the end, but if the audience has clarifying questions, I think you can chat those, and I'll try to pose them to our panelists. But we're going to go through an order, starting with Mike Conathan. Mike is a senior policy fellow in the Ocean and Climate, Energy and Environment Division of the Aspen Institute. And Mike is going to help level set us on some of the policy activities occurring in this space. Next, we'll have Christian Meinig, who's the Director of Engineering at NOAA PMEL, Pacific Marine Environmental Lab. And Chris is going to talk about ocean observing and carbon dioxide removal, and how we can start to understand how the ocean could potentially pull additional carbon out of the atmosphere, and how marine energy could potentially be used in that endeavor. Next will be David Hume. Dave is a marine energy manager at Pacific Northwest National Laboratory, currently on assignment to the US DOE. And Dave is working to pull the threads together on a larger DOE cross-government maritime decarbonization strategy. So he's going to give us an update on that. Katie Morris and Simon Gore, both from the US Department of Energy Water Power Technologies Office, are going to tag team on a presentation that looks at how communities are part of the solution for ocean-based climate approaches. And they're going to talk about some of the WPTO's recent efforts to promote resilient coastal communities through various mechanisms. And then finally, Jennifer States will take us home. And Jennifer is Vice President of Projects and Strategy for Washington Maritime Blue. And she's going to talk about how we actually organize around some of these opportunities and challenges through collaborative and cluster-based models. So with that, and finally, after our presentations, our discussion will focus on the following 4 questions. So I'm going to put these up here so you audience members can start to kind of think about this, and maybe the panelists as well. But how do we leverage ocean-based climate solutions to drive new dialogue with coastal communities, present new opportunities? What are the solutions, and what role could marine energy play as part of the solution set? How do we approach these solutions aligned to underlying values of equity, environmental justice, economic opportunity, and sustainability? And finally, what are the mechanisms to engage with innovators through public-private partnerships and emerging cluster organizations? So without further ado, I'll stop sharing, and Mike, you can start talking.
Right on. Well, thanks, Simon. I appreciate the opportunity to be here today and sit in pole position and kind of kick things off. I get a little bit of the easy job here, where I get to do the big picture stuff, and then the smart people can come in and tell me what's really actually happening. But I'm going to just provide, as Simon said, just a little bit of an overview of what both the policy and the political landscape look like when it comes to the ocean in general and ocean-based climate action in particular in the Washington, D.C. space. I should, I guess, start by saying that, you know, I did the only sensible thing you can do after you spend a little bit of time in D.C., which is get the hell out. And I now live in Portland, Maine. So I'm much happier up here. It's a very nice place to be, and I get to be away from all of that fray. But my background is, you know, the one thing that I did like about working on ocean issues in D.C. primarily is that it's even today remains one of these sort of bastions of some semblance of, I won't call it bipartisanship, but really nonpartisanship. And I want to talk a little bit about that and how it relates to the ocean spectrum as well. I started out working for a Republican senator from Maine, Olympia Snow, and the Republican ethos didn't quite sit right with me. It was a little too cold. And then I jumped over to the Center for American Progress, and I ran an ocean program for them, sort of progressive left-leaning organization in DC. And that was really valuable, focused on blue economy stuff, but I overall seemed like a little too hot. And now I'm with the Aspen Institute, which is a nonpartisan convening body that sort of pulls people together. And like in true Goldilocks fashion, I feel like we finally hit the nail on the head a little bit here. This is where I like to be. I like to sit in the middle, find the compromises, find the opportunities for collaboration and sensible policy action. And I wish we had a little more of that going on in DC now. But for as I mentioned, you know, the ocean and ocean-related issues really tend to be much more nonpartisan than a lot of other things, obviously, that are taking place in DC now and really ever. I was in the Senate about 15 years ago when we thought things were contentious, and Simon was with me there working for Senator Cantwell, and we had no idea where things were going, obviously. But I find that some of the issues that ocean action faces in particular in DC have a lot more to do with issues of understanding, with issues of complexity in the policy landscape, and the perpetual sort of change of leadership. I think, first of all, in the policy landscape, as I know many of you are well aware, there are literally dozens of federal agencies from over 10 different cabinet departments, plus the EPA, plus NASA, plus the National Science Foundation, that all have a piece of jurisdiction over ocean-related issues. So when we talk about doing things that affect the ocean, it's never simple because there are always, you know, a ton of different bureaucrats who have to come to the table. And of course, you know, no offense to present company, but federal agencies really like to protect their turf, and they don't always play well with others. And so one of the things that we've been working on very closely is trying to figure out how to find some of these points of interagency collaboration as we look at the opportunities that are existing right now in the ocean climate space, and what we may have to gain coming forward. Add to that the fact that the ocean is inherently a literally fluid policy landscape where jurisdiction is squishy. There are incredibly complex diagrams. I chose not to do slides because I was lazy, I don't know, but there are incredibly diverse jurisdictional boundaries that exist in the ocean at 3 miles for states and 12 miles for territorial sea and 24 miles for the contiguous zone and 200 miles for the EEZ, and then beyond that it's international waters, and it's a complete Wild West out there. So the ocean is also incredibly difficult to manage just from a straight up governance perspective. And everything, of course, transitions across boundaries if you do anything that actually has any kind of movement to it in the ocean, whether that might be fisheries management or carbon dioxide removal, and where does it go? And all of these questions make it incredibly complex. And I'm going to come back to fisheries in this context because fisheries is really important for a lot of reasons. And some of it has to do with energy as carbon, as Simon mentioned in the beginning, and the potential carbon removal and carbon reduction drawdown potential of decarbonizing the seafood industry and lowering the carbon footprint of our protein creation in general. But fisheries are also really weird politically, and they are incredibly deep-rooted and cultural in a lot of different components of the country. And so they tend to have significant outsized political impact, and they really punch above their weight in a lot of these conversations. And so I want to come back to that in a little bit as well. A word too, just about sort of the difference between policy and politics and how they play together in this space. And I apologize if this is all rudimentary, but again, as sort of the lead-off guy, I get to kind of pick what I'm going to say. And I think this is an important distinction, and I want to just spend just a quick second on it. That when we talk about policy, we're talking about the what issues of what we want to accomplish and what's going to set the country on this right path to success in the world. And in this case, what can the ocean do for us as a weapon against climate change? Like, these are the policy questions, and the political questions really come down to the how questions. The how do we come to some kind of agreement? How can we convince people that our ideas are right? And if we can't convince people that our ideas are right, then how do we create enough momentum to just cram these things through or find loopholes to make things happen so that we can actually get to positive policy change? And so we've got to put both of these factors into play when we think about where we're going in this sort of ocean climate action space. And again, this gets weird with the ocean because it doesn't fall into the sort of traditional Republican Democrat paradigm that we see play out so often in DC, especially these days, that conservative progressive balance. It becomes so much more about geography. And in many ways, that makes it a little easier to get some things accomplished because we can fly some stuff under the radar. We can make these sort of strange bedfellow connections with bipartisan leadership, and we can find that progress. But it also sometimes makes it difficult to get the sort of heat of the spotlight and the attention on our issues in a way that's really what drives things across the finish line and what gets policy implemented. So that's part of the challenge that we face right now. But the reality is we do have kind of an unprecedented, at least in modern history, opportunity right now to get at some of these potential solutions. And Simon was alluding to these in the beginning, talking about what the high-level panel has said about this potential for oceans to contribute, 20%, a fifth of the drawdown necessary to implement these emission cuts that are necessary to stick to that 1.5 degree target. And in those 4 categories that he was talking about, which I don't have to run through again, there are also some other tangential things that are out there as well. We can talk about biofuels a little bit, thinking about ocean minerals and the future of, is there an opportunity to get some of these minerals from the deep ocean in some kind of a mining capacity, and is that sustainable? And a lot of these conversations and the controversies just pop up like crazy around a lot of these things. So there we see these opportunities to get this sort of clear commitment and dedication to climate issues. It's becoming less of a conversation about, it's certainly not a conversation now about, is climate change happening? I think there are very few folks even who have been in the sort of climate denier side of the equation who are still trying to make the case that climate change is actually a hoax. The question now becomes, what are we going to do about it? What are the costs of potentially taking action? And how can we find ways to move forward? And for our purposes, it's what role does the ocean need to be playing, and what role should the ocean be playing in these conversations? So here we think about the hurdles, again, as to why the ocean isn't a bigger part of the conversation already. And to me, there's four that sort of tend to rise to the top of this. One is just sort of general ignorance of the opportunity, that the ocean is always an afterthought in a lot of these policy conversations. No politicians' constituents live on the ocean, or very few. I guess there are some houseboat people. Shout out houseboat people. But for the most part, you know, you're on land, you're in a district, your congressional district might include some coastal space, but particularly as you get further away from shore, there aren't a lot of constituents speaking for it. And so that ocean always remains kind of an afterthought in the political structure. The complexity of governance structure, which I alluded to earlier, the lack of stakeholder agreement around what to do about ocean issues, I think, is a really fundamental concern here. You know, I work quite a bit with the ocean NGO community, the environmental groups who work on ocean issues. And while they all agree that the ocean needs greater protection and the ocean activities need to be sustainable, that means a lot of different things to a lot of different people. And so in coming to policymakers to say, you know, we need to take action on climate by pursuing sustainable aquaculture, for example, that's not at all a universally held position of a group of advocates that policymakers look at as being somewhat monolithic. People say, what do the ocean conservation groups think about this issue? They think 7 different things about the issue of aquaculture. So we have a bit of a communications problem within the advocacy and stakeholder community. And then fourthly, this issue of conflicting uses. And this brings me back to the fishing industry example a little bit, where you've got one industry that is very near and dear to the hearts of communities, particularly where I am in New England and where many of you are in the Pacific Northwest and Alaska. And they are used to being the only game in town. And so they, as they see emerging new uses coming in, whether it's aquaculture, whether it's offshore wind or other forms of marine renewable energy, their immediate reaction is to push back very hard against that. And they have a lot of supporters in their political constituencies that make these obstacles really grow and loom large. And we see that, I think, especially in offshore wind. You know, that's sort of the key example of this, where offshore wind is a proven technology. Europe is using it to great effect and has for decades now. We have 5 offshore wind turbines currently operating in US waters. They're all in state waters because nobody can agree how to site them in federal waters. And that is exclusively because we cannot figure out how to come to any kind of agreement or reasonable stakeholder participation process with the fishing industry. So these are the kinds of things that really make it difficult to move forward and capitalize on these opportunities that exist. We've got these sort of shifting political winds that have started to blow in our favor a little bit with a new administration that purports to be taking climate change very seriously. But even there, we see that they are perpetually getting beat back by the opposition that doesn't want to spend the money. And even as they are moving forward, it's been very difficult to find those places where we can really prioritize the ocean as a climate change solution. And yes, there are some mandates out there, 30 gigawatts of offshore wind by 2030. Nice round numbers. Everybody likes nice round numbers. The political realities of actually getting that implemented are going to be a massive challenge, and we're already seeing the legal challenges there. So I think as we think about how to clear away these obstacles and how to take advantage of these opportunities, you know, to me, it sort of comes back to this whole position that I've sort of set up my career of operations, which is in this place of compromise, which is in this place of bringing all the stakeholders to the table, figuring out a path forward that starts to address some of the concerns where they feel like even if they don't get a decision that goes in their favor, they've at least been heard and listened to, and that we can really push through and create some of these compromise positions and solutions where we get not only policies that are successful and take advantage of these opportunities, but can also be durable and are not just going to be reversed by the next administration that comes in when we get another shift of political winds. I think about the issue of the Pebble Mine, which I did a fair amount of work on when I was with Center for American Progress in particular. That was deep. This is a big mine in the wilds of Alaska, in the headwaters of Bristol Bay, that was basically banned, blocked under the Obama administration, came back like a zombie under the Trump administration, administration, now has been banned and blocked again under the Biden administration, but we can't ever really celebrate one way or the other because every time a new administration comes in, things change. And no one's going to win in that scenario. We're not going to end up with positive policy. So we've got to figure out how to get past some of these and get to the durable policy solutions that can exist with these opportunities. So that's my overview. I'm happy to take any questions as we go forward, and looking forward to hearing the other presentations as we get into the real nuts and bolts of what we're talking about here. Thanks, Simon.
Thanks, Mike. Lots to unpack there. And I think you set us up for a good discussion around how we bring groups together around some of these issues. And one of the things I really like about the ocean-based solution framework is that there are ways for all groups to contribute to decarbonization in an ocean-based strategy. Seafood is a key part of that. Working with industry is a key part of that. And so I think one of the questions I'm going to be asking you guys all is, how do these kinds of solutions help create new dialogues that maybe are different than some of the dialogues we've had in the past? So you teed that up nicely. Next panelist, I don't have my order in front of me, but by memory, I think it was you, Chris. Is that correct?
Yeah, that's right. Can you hear me? Just a sound check?
Yeah, we hear you and I see your slides.
Okay, wonderful. Well, that was great. Mike, you really did tee it up well in understanding that the science is clear for climate change. It's really about human change at this point. Can we rise to the challenge in our human design systems? Hi, everyone. I'm Chris Meinig. I'm Director of Engineering at NOAA's Pacific Marine Environmental Lab, and I'm going to be presenting some marine carbon dioxide removal research interests and also connecting that to some of the marine energy aspects to this as well. And a lot of the materials here I'm presenting on behalf of our NOAA Carbon Dioxide Task Force, which is a group of 50 people. I'm the only engineer on there, so I'm feeling like I'm very fortunate to be part of this dream team that's been collected here, and the amount of knowledge and understanding about carbon dioxide in the ocean and the challenges that faces us is really tremendous. So I'm really fortunate to be part of this team. I'm going to start off here on presenting some IPCC data. It's really the graph on the left, right? As we look at what we're facing up against, that eventually we're going to have to once we bring some of these conventional abatement technologies into place, which is things everyone's heard about, we still are left with certain stubborn emissions that we're going to be forced to deal with, and that's going to create the necessity for a negative emissions targets, and that's really what we're going to focus on here. And they're quite large. If you look at them, they're quite large. I want to state flat out, this is no reason for us to delay and not to do the immediate things post haste. We need to decarbonize immediately. Negative emissions and in the ocean in particular is not an excuse not to do the easy things. All these other things we're talking about are much less certain and present other uncertainties that are around there. But nonetheless, we're ultimately going to be needing to take on about 10 gigatons per year out of the ocean or atmosphere, and the ocean and atmosphere are equilibration, equilibrate, and so one will take it out of the other. So what does that look like? If we start at 2020, that's like a 6% annual growth rate that we'll need to grow our net emissions technology. To put that in the frame, that might sound like a scary number, and it's an awful lot of carbon that we need to sequester. Solar panels are presently at 30% year over year. Electric cars are something like 20%. They didn't start out that way, but we got up to speed and momentum fairly quickly. So this is not an unattainable solution, but we just need to get busy and motivated immediately. There's multiple agencies. Mike talked about this. I'm not going to show this slide, but just know that there's a tremendous amount of alphabet soup across government agencies involved in this, and places like not-for-profit EFI are recommending something like $11 billion over the next decade to be put into this. Okay, well, why don't we talk a little bit about specific techniques that we talk about that are available to us. I am not going to be able to cover them all. Specifically, I'm not going to be able to talk about blue carbon, which is nature-based solution. But I figured I picked the top 3 here that I thought this crowd would be most interested in hearing about. And that would be direct electrochemical CO2 stripping out of the ocean. So that's an engineered removal and storage of ocean CO2. The biotic cultivation, so that's seaweed. We think about that a lot, of how we do that. What do we do with it? How do we sequester that? And then enhancing through alkalinity enhancement processes. Now, these are natural processes that already go on. Might there be a way to accelerate that, or for people to do things with that to make our carbon pump go faster? There's several things already underway. So there's research underway by these researchers and universities where we're talking about connecting to large platforms and having some type of electrical input, right? That electrical input, if that's not zero carbon footprint, then it all doesn't work. So this is a huge role for renewables to draw down the CO2 out of the ocean and then do something with it. This direct carbon capture method needs to happen at multiple scales before it's proven out, and there's presently nothing that is going on. Carbon dioxide removal via kelp farming, more mature. We're seeing more and more kelp farms come up. The science isn't clear on this, on exactly what this does to the remaining part of the ocean. So there's huge opportunities in those cross-cutting things. Might this enhance fisheries? How many jobs does this provide? What do we do with the product? Is this a biofuels alternative? So there's tremendous opportunity in the macroalgal technique. This is one example we did in Hood Canal that understood a little bit about the difference between the kelp and various parts in the kelp farm, but certainly much more research needs to be done. Ocean alkalinity looks something like this, where we take natural weathering stones. There's like olivine stone, and there's natural chemical processes that can happen. Here's this nice long equation on the bottom of how do we do that, from riverine inputs to factories that put minerals into the ocean and ultimately comes into form sediment and limestone. How do we enhance that? How do we do that responsibly? How do we not screw this up like so often humans do? We think we know what we're doing, and then we end up screwing up. More research is needed. So NOAA is really well positioned for doing a lot of this. We've got observing technology development to understand how we frame these things properly. We can couple that to modeling. We can understand that to ecosystem responses, these significant co-benefits that we talked about with societal, making jobs, and understand how that all fits together in a working and functioning and equitable society. Marine spatial planning, as we heard, is key to this. We cannot keep going on and fighting between these boundaries in the ocean and expect to make any progress. This is significant systematic change that's going to be needed. So there's things to build on, right? So we already have a global ocean carbon network to help us understand the natural variability. Just to be clear, what you're seeing on the map here was designed not to understand any man-made, but to understand the natural variability of what's going on in the ocean, which is poorly understood. We don't fully understand what's going on. There's certainly more research that's needed, but we're understanding more and more simply because we have lots of sensors and lots of networks in place. Here's a good example that I think we can take as just a case study. I could have put several things up here between buoys or sensors. I chose a sail drone one because it's pretty exciting both in speed and scope, where we've developed public-private partnerships in research and development and had significant benefits. Now, the challenge is for the marine energy community, there's more to do here, right? We've done a lot with sensors, and the case study I'm going to show you here, it revolves around sensors. But as an engineer, if we had more power available that we could harness effectively from the ocean to do this, we would be doing other things, right? So let's just step through this. Sail drone is a 7-meter long vehicle to give you some sense of it. The sensors over here, we've developed through a cooperative research and development agreement between NOAA and Sail Drone, 14 different sensors, everything from making maps to insonifying fish, to understanding carbon fluxes, to the things that you would expect out in a buoy weather station. We've done all that to great effect. And in 2019, we were the first autonomous uncrewed system to circumnavigate around Antarctica. We measured carbon measurements during that entirety. We had power regen. So that's a first ever. Sail drone is now expanding, right? If you thought 7-meter was big for an uncrewed system, now they have a full-on 22-meter vehicle that is making full-on bathymetric maps to full ship capacity, right? At almost zero carbon footprint. This is happening really fast. Now, typically from that previous map I showed you in the ocean space, my experience has been, whether it's say a global carbon system map or a global tsunami warning system, things we do in the ocean typically take about 10 years. As I started this effort here, I said, 10 years is not going to get us done. We don't have many decades left. We need to move faster. We need to accelerate these human systems. And in 5 years, we've been able to get 500,000 nautical miles and over 1,300 days at sea with some really significant firsts, right? The circumnavigation around Antarctica. We had a tremendous COVID fisheries response. When we could not launch ships, we could launch drones. So that was a big win for us in 2020 to still be able to push these off the dock, have them go clear up through the Bering Strait, all the way around Alaska and to the Canadian border and back again during COVID things. And just a few months ago, they did a full multi-beam mapping effort for the first time. So here's an opportunity for marine energy. I present this as a template of how we did this for sensors. I think energy could follow this template, and I'd love to engage with people to talk about this. If we had more power that we could simply develop in these timelines, which is like develop an agreement, do small integration, field validate, and demonstrate success, as we have done for these sensors in the marine space, there's other things we could do, like track the fate of the carbon. We could extend our operations to higher latitudes. We could attach profiling LiDARs, which give us a better idea of offshore wind and the marine boundary layer effects that are going on. And we could greatly transmit higher quality video back, which would give us greater marine domain spatial awareness and all the things that you would like. You'd have to have eyes out in the ocean. So here are the teams that are setting up, right? Cross and interagencies, alphabet soup. I'll say their opportunities here really are through NOP. There are ways for public-private partnerships to be established in collaboration with communities and science agencies in order to do these things in a new way, like Simon said. I believe the examples are, these are building efforts where we're not just serving one customer, but if these were offshore, if the sail drones were offshore and we were making better maps, we understood more about our fisheries. And oh, by the way, we're helping understand the carbon fate, and we're producing data that helps offsite offshore wind or energy. That's the triple bottom line that I think we're going for. So thank you so much. I present here some links if you want to learn more about marine CDR for people to digest.
Great, Chris. We'll leave those up for a second. And well, maybe we won't. But I'm wondering if we can share some of these slides. We'll work with Jason to at least share some of these links, because he had a lot of great material there. And I'm looking at the chat. If anybody has clarifying questions for Chris, you covered a lot of ground there, ranging from CDR and why we're doing it, to how do we measure it, to broadly speaking, for thinking about ocean-based climate solutions. We need all kinds of new measurements, whether they're fisheries measurements, carbon measurements, air measurements, tracking maritime decarbonization strategies. So I think you opened up a nice Pandora's box of things we can discuss later. Thank you for that. Let's see, looking at the chat here, just to double check to see if we have questions. I don't see any. I think we're going to switch over to our next speaker, which is David Hume. And Dave will talk about what's happening in the broader maritime decarbonization space. So take it away, Dave.
Thanks, Simon. And that's a tough act to follow there, Christian. Thanks for that. So hi, everyone. My name is Dave Hume. I'm a Marine Energy Manager at Pacific Northwest National Lab on detail to U.S. Department of Energy, supporting on maritime decarbonization work. As Simon said, I'm going to give you a very, very brief overview of the maritime industry, as well as the maritime energy transition that's currently underway. It sounds like we'll do questions at the end, so if you do have any, just drop them in the chat, or we'll get them at the very end there. So slides work here. There we go. So to start, just want to acknowledge what we're talking about when we talk about the maritime transport sector or the maritime industry. It includes the domestic and international network of ships, seaports, and all the associated infrastructure that goes along with it. Maritime transport is one of the largest sectors of the blue economy. It really does facilitate other sectors, including oil and gas, or fisheries, or defense as well. And I'm sure all of you have heard this factoid before, but if you haven't, close to 90% of all world trade is carried by ship. That is truly a staggering number when you think about it. Of course, this is one of those industries that's kind of out of sight, out of mind, as Mike mentioned earlier on in his presentation. Not a lot of people think about shipping up until at least we saw a ship get stuck in a Suez Canal a couple weeks ago or months ago. Really wasn't the first thing that people think about on a day-to-day basis. But it is a very large industry. It does have a large amount of emissions associated with it. So currently, the greenhouse gas emissions associated from global shipping is about 1 gigaton per year, or about 2.9% of global greenhouse gas emissions. If we were to rank international shipping as a country, in terms of the top CO2 emitting countries in the world, it would rank number 6, just above Germany. So it's truly a staggering amount of emissions associated just from ships that carry our seaborne trade. There are a handful of international regulations that are currently trying to regulate the amount of emissions that come from shipping. And in addition to that, there are a number of customer and market forces that are really demanding action on climate change. So all this is really leading to what can we do to help reduce emissions from shipping, and it's really leading to an energy transition in the maritime space. Of course, when we talk about emissions, we need to talk about energy. And there are a variety of different ways that energy is consumed and utilized in the maritime space, both by ships and in ports. What I'm showing here are just a handful of some of the different ways it's consumed, whether it uses energy for main propulsion on a vessel, electrical generation, whether on ship or on shore, or for producing lighting or moving cargo around the port. A variety of different ways that energy is consumed and used. If we narrow in on the ship, I want to note that every ship is unique. I'm sure all of you saw the Ever Given that was stuck in a Suez Canal, but that's just one type of ship that exists. Container ships, very large crude carriers, product tankers, offshore wind supply vessels, tugboats, push boats, lots of different commercial vessels out there. And they are as varied as the missions they serve and the cargoes they carry. So ships can carry anything from containers to cattle. It really just depends. And of course, with such variance in the size and shape of these ships, the energy demands and load profiles will vary significantly as well. Even the same ship that is the exact same vessel that is operating on different routes may have vastly different energy demands. So just give you an example of how much energy we're talking about for one typical ship. Shown here on my screen is a Maersk EE class vessel. This is not the largest ship in the world anymore. It was back in like 2016. It has been surpassed numerous times now. I think the largest ships in the world are about 30 to 50% larger than this ship. But this vessel here is rated to carry about 18,000 20-foot containers in one single voyage. The main propulsion diesel engine on this vessel is rated for about 60 megawatts, which is about enough power for a small town or city. In addition to that, there are several small auxiliary diesel generators on board this vessel that are each rated for about 2 to 3 megawatts. When this ship is underway, it'll consume about 100 to 200 tons of fuel every single day. When it's in port, it is still consuming fuel just to power the cargo handling equipment on board the vessel. So these ships use vast amounts of energy. And as I said, this is just one vessel. If we look at the global international fleet, there are between 50 and 80,000 ships that make up that global fleet, each one using about similar amounts of energy. Now, if we look throughout the ages here, I don't want to give you a history lesson. I think this is probably something everyone knows here, but throughout the years, going back to early 1600s, we've used a variety of different forms of energies on ships. Start off with sail power, transition to coal and steam, and then really ever since the early 1900s, we've been using what's called heavy fuel oil, or HFO. And as you can see here, we've been generally trending towards energy sources that are cheap, readily available, and very energy dense. As I mentioned earlier, we are in the midst of another energy transition right now. You can see how these are generally spaced about 100 years or so apart. And as Chris said, we are really at an immense opportunity right here to understand what is this next fuel or fuels going to be that will help the industry transition away from HFO. And for those of you that are unfamiliar with what heavy fuel oil is, it is quite literally the bottom of the barrel when we talk about fuels. When we refine raw petroleum, it is literally at the bottom of the refinement chamber. So you get these lighter distillates like diesel, kerosene, and naphtha closer to the top. And heavy fuel oil is what's left over. It's one step above what we use for paving our roads or asphalt. When we burn it in ships, we have to heat it up to about 130 degrees centigrade just to pump it because it is so viscous. I know from personal experience just how nasty this stuff is because I've had to clean it numerous times when I worked on ships. It is nasty, nasty stuff filled with very nasty chemicals and heavy metals and all sorts of other nasty crap that we just don't want to deal with. Sorry for swearing. And when we burn this stuff, as I mentioned earlier, it does lead to vast amounts of emissions. So that Maersk EE class vessel I showed you earlier burns about 100 tons of fuel or 100 tons of HFO every single day. And so currently we're producing about 1 gigaton of CO2 emissions each year from the global maritime fleet. If we do nothing and continue on this course and let shipping run its normal course of action, we're likely to see emissions increase by about 30% over where they are right now. However, as I mentioned earlier, there are international regulations that are trying to reduce emissions. This is largely specified by the International Maritime Organization, or IMO, which is a UN regulatory body. They have set for themselves a 50% reduction by 2050 relative to a 2008 baseline for global greenhouse gas emissions. As you can see here in this chart, though, what the IMO goal is a 50% reduction, and where we are heading right now, given the current modeling efforts, they are not aligned. We need to bend that arc back down the other way. Fortunately, there are a number of different emission reduction measures and fuels that can help us get to where we need to go. I've showed this chart not to confuse you, but to just show there's a lot of different opportunities out there that exist for helping us reduce emissions, whether it's different fuels such as green methanol, green ammonia, green hydrogen, energy efficiency measures such as wave foils, air lubrication, or supplemental propulsion. All these different ways can help us reduce emissions. The challenge will be understanding which are the most viable pathways that we want to focus on and which ones will lead to the most emissions reductions or have the most impactful on the industry in the short term. When we consider replacing HFO specifically, I want to call out that when we look at alternative fuels such as methanol, ammonia, or hydrogen, it's important to consider not just how many emissions are associated with combustion of the fuel when it's in the engine, but also in how the fuel is produced. So the fuel production pathway is extremely important, because if we're producing emissions and producing the fuel, that really doesn't help much if we're not offsetting those at all. And so when we consider about fuel production, we need to consider full life cycle emissions, or well-to-wake emissions of these fuels. Some of these fuels can be produced through electrochemical pathways, what we call electrofuels. And so those will be something to consider going forward. If we want to focus in on this electrical flow or electrification, I want to show this chart because I think it's really eye-opening, at least in my opinion. So when we think about electrification as one potential pathway for decarbonization of the maritime sector, there are a couple different ways we can use electricity, not only to produce electrofuels, but also as recharging batteries on either all-electric cargo handling equipment or all-electric vessels. We can also plug in ships to shore power, what we call cold ironing, or there's other aspects as well. But I want to show this study that shows, through a modeling effort across the United Kingdom, looking at all ports in the UK, they have forecasted that under an aggressive decarbonization scenario out to 2050, they're seeing an increase in electrical energy consumption at the ports, going from 20 gigawatt hours in 2016 up to 4,000 gigawatt hours in 2050. That's under an aggressive decarbonization scenario, admittedly. However, it is a substantial increase in electrical energy consumption, and this is going to be largely concentrated at ports. How we meet this is going to be extremely important, and it's going to require substantial amounts of renewable power, not just solar and wind, but also other co-located marine resources like wave and tidal as well. So just to quickly summarize here, maritime transport is a very critical sector to the blue economy. It interfaces with other sectors such as defense, fisheries, and offshore energy. Lots of interconnections between those two. When we talk about maritime transport as energy transition, it is truly a once-in-a-century opportunity, and it's going to happen both at sea on ships and onshore in our ports. We're going to need lots of new technologies, fuels, and operational measures to be deployed rapidly to help reduce emissions as quickly as possible. And currently, the rate of deployment is not really where it needs to be, especially we want to start bending that arc down to a 50% goal that we really specified at the IMO. Fortunately, there are a number of state and federal government agencies that have multiple mechanisms through technical assistance, funding opportunities, grants, or other mechanisms that can help support the industry throughout this transition. And they are looking for ways to help collaborate and work with other industry partners. So if you have any interest in collaborating there, please get in touch and I'll try and connect with the right people. And with that, I think I'll end there. Thank you very much.
Good job, Dave. That was a quick march through a very, very tricky problem. And I think maritime is so fascinating because it's such an integrated problem. You talked about you need solutions on the battery side, the energy storage side, the microgrid and grid and utility side, plus fuels, electrofuels, so renewable power required. So it is one of those, pardon the pun, all hands on deck type of challenges. So thank you for that. I'm still not seeing questions from the field. I do see people are here. I see there's 58 people. Oh, I got one. Well, maybe we'll take this one for the final chat here. About how we use LCOE as a metric to think across some of these issues. So we'll save that question. Well, it is for you, Dave. Diane Baldwin says, your arguments are compelling. How do we get past LCOE as the only criteria for marine energy? And I think that is sort of a broader question than just maritime, but how do we sort of think about some of these multiple value / use cases for marine energy where it might be particularly compelling for any one sector? So for example, ports, or for Chris's example, ocean observing. And as you know, we have an ocean observing prize right now within the DOE Powering the Blue Economy initiative. And so maybe Simon and Katie, our next speakers, can kind of talk a little bit about LCOE and talk about the value of marine energy in unique situations. I know you guys are about to talk about how coastal communities might value these technologies in unique ways. So I'll use that as a lead-in to introduce our next speakers, Simon Gore and Katie Morris from the Water Park Technologies Office. And you guys are going to kind of tag team it, right? So,
yep.
All right, go for it.
Yep. Well, good afternoon, everyone, and thank you for the opportunity to share with this crowd some of our initiatives at WPTO, specifically our community-focused work supporting the Powering the Blue Economy initiative and how they might support an ocean-oriented climate agenda. My name is Simon Gore, and I'll be giving this presentation in collaboration with my colleague, Katie Morris. I manage the Resilient Coastal Communities portfolio at WPTO. This focuses primarily on marine energy tech applications in remote communities. issues of resilience. We have a focus on desalination, and then we have some additional work that's focused on community-driven processes. I think it's really important to note that the energy challenges in these communities are at least as technically complex and often more costly than they are in our larger mainland grid locations. Yet the stakes are often more significant, and they've often been overlooked in our traditional focus on large-scale renewable energy transitions. But ultimately, our thoughts are that marine energy can play a significant role and a unique role in these communities. Next slide, Katie. Yeah, so just to reframe that a little, coastal communities are at the front lines of climate change, and they do have adaptation issues. They also have a real focus on sustainability, so they're reducing their carbon footprints and also trying to understand energy and community resilience and how those are specific areas of interest for coastal communities. When we think of the long-term evolution of the coast, these will need to adapt and develop resilient and equitable solutions. That's more than just saving the beach. That's thinking about how do we provide basic things such as energy and water in the future. And so we see that as a potential opportunity. In many of these communities, there's a dependence on costly imported diesel fuel. And that's, at its base, that's a lack of resilience. And that's, to the WPTO, that's a clear economic opportunity. And then just finally, I just want to give a really broad description of how we think about resilience at WPTO. And that's, we explore it across both ecosystems, energy, and coasts. And we've made it a core priority of PBE. And it's definitely, our main focus is in working with communities. Next slide. Yeah, so just to go over one of our biggest sort of investments in this space, and that's the Energy Transitions Initiative Partnership Project. That's to provide holistic energy planning around both energy, strategic energy goals, and energy resilience in remote coastal and island locations. We take a multi-stakeholder, multi-technology approach, and so that means we're effectively providing comprehensive technology-neutral technical assistance that aligns with the community's identified challenges, community values, and then community objectives or goals. And on the image on the right, you can see the current communities we're working across. There are 5 up in Alaska that range across the state. We've got 2 communities up in Maine, 2 in the Outer Banks, and then 2 in the Hawaiian Islands. And just to note that this is across multiple renewable technologies at DOE. Next slide. Just to break down that program a little more for you guys, we have these regional partner organizations that provide essentially engagement and outreach. And those are the 5 organizations on the bottom left. So that's the Alaska Center for Energy and Power, the Hawaii Natural Energy Institute, Renewable Energy Alaska, the Islands Institute in Maine, and then the Coastal Studies Institute in the Outer Banks. And then the technical experts or the technical expertise is provided by the 4 national labs you see above that: Berkeley, NREL, Pacific Northwest, and Sandia National Labs. And the way the framework works is that we have a process where the communities essentially identify what their energy challenges are, how they define energy resilience, and then what their goals might be in the resilience space itself. We then deploy this partnership structure to organize around these communities and provide assistance to meet resilient energy systems. So really the point of ETIP at some level is to connect communities with the energy experts to advance energy resilience in these communities. Next slide. Breaking that down a little more, I just want to cover what we mean more specifically about energy resilience as a specific case study. One of the examples is we're working with Eastport, Maine. The type of defined assistance that we're providing is to help support sizing and siting of a potential microgrid. We're looking at analyzing the operational issues over that system and then what the potential might be for marine energy as baseload power. And then we're also trying to help them understand how these scenarios might fit within their broader strategic community energy and resilience goals. Next slide, Katie. And then there's also a focus that fits within this narrative today of maritime decarbonization. We're working with the Alaska Longline Fishermen's Association, ALPHA. Specifically there, the labs are trying to help or evaluate what retrofit options might be for that fishing fleet. That can look across both near-term solutions that are more hybrid solutions to longer-term futures around full electrification. Another example is Ocracoke and working with the local utility there to think about planning for electrification of that ferry fleet. What's interesting there is that they don't just define resilience as connection to the mainline grid, but thinking about the future of ferry vessels in that location. So that's thinking about capacity improvements shoreside, but also the operation of these fleets in the future. And then I just want to end this particular note that we're focused on small ports. We see them as critical nodes of energy innovation and community impact. And we also see these three key issues arriving there: electrification, resilience, and sustainability, all driving important opportunities in the future. And with that, I'll hand it over to Katie.
All right, thanks, Simon. So some additional areas of interest relevant to coastal communities are aquaculture and blue carbon. And right now, the aquaculture is more under the Power at Sea initiative within the Water Power Technologies Office, but we also have recognized that there are implications to communities. So aquaculture provides a sustainable source of seafood and can be a good source of protein. And it can also help to foster resilient coastal communities through the creation of jobs, as well as supporting working waterfronts. So shellfish and macroalgae aquaculture can also help to improve water quality and provide habitat, as well as reducing storm surge. And Chris mentioned this earlier, but kelp farming can also be a solution for carbon dioxide removal. So the Water Power Office is interested in on multi-fronts. And then blue carbon ecosystems help to contribute to climate mitigation by sequestering carbon and providing essential ecosystem services, one of which is coastal protection. And environmental monitoring for both aquaculture as well as blue carbon ecosystems could potentially be powered by marine energy. So we're interested in looking at what are the environmental monitoring needs across these different areas and how marine energy could potentially play a role. We also see that there could be a potential role for marine energy to power aquaculture activities, including feeding systems. Next, I'd like to highlight our recent collaboration with the National Sea Grant Office. In 2021, a cross-agency request for proposals was released to advance research on the effects of ocean renewable energy on coastal communities in the Northeast. So this was a competitive research opportunity that was funded by the Department of Energy's Wind Energy Technologies Office, the Water Power Technologies Office, as well as the Northeast Sea Grant Consortium and NOAA's Northeast Fisheries Science Center. So it's pretty unique in that most of these entities have not previously partnered together, but I think it presents a really interesting way of working forward as it relates to coastal communities. There are three research priority areas, which include fisheries and fishing community resilience, coastal community and economic resilience, as well as multi-use marine activities. And the latter refers to essentially where you might have co-location of a wind farm and aquaculture activities. And so really interesting to look at what these various marine activities and how they might be co-located to take advantage of siting of multiple activities out at sea. We anticipate awards being announced sometime in the next 6 months, so stay tuned for a future announcement. And what we've really seen through this is that this partnership has been a really effective model for how a regional consortium that can help to advance some of the research as it relates to coastal communities. And so I think we're really interested in how this model might work in the future as we continue to pursue opportunities working with coastal communities, especially on a regional scale. And one priority that has also emerged within the Biden administration and across the Department of Energy is focused on energy equity. So remote coastal communities face unique energy and infrastructure challenges and are on the front lines of climate change. And earlier this year, President Biden announced the Justice 40 initiative that seeks to ensure that at least 40% of benefits from federal investments in climate and clean energy go to disadvantaged communities. And also, I would like to note that the Water Power Technologies Office is committed to advancing these goals and intends to launch a new Inclusive Energy Innovation Prize. That prize will award organizations to support entrepreneurship and innovation in communities that have historically been underrepresented and underserved in the energy sector. To finish up, we would like to just summarize some of our thoughts with regards to resilient coastal communities. So in order to advance the Water Power Technologies Office's resilient coastal communities interests, we're really looking to advance technology optimization for future provisioning of energy services and innovation in the blue economy. There will be an emphasis on designing ocean-based energy systems as well as climate-focused actions. And critical to this work of developing ocean energy solutions is to have communities equipped to make their own energy choices while also considering other community values and ecosystem services. So overall, we recognize that a community-based approach is an important pathway for ocean-based solutions, and we believe that working with communities could really help to foster greater enthusiasm for energy transitions and climate solutions. And that wraps it up. And perhaps we can address some of the questions that were brought up by Dayan in the discussion section. So thank you.
Excellent. Thank you, Simon and Katie. That was really a perfect segue into our last speaker. I think your comment about how do we put communities first and how do we bring folks together around some of these issues in new ways does create opportunities for new models of collaboration. And so Jennifer States is going to talk a bit about that. And Jennifer, I see your presentation is pulled up. Are you ready to go?
Yep. Can you hear me okay?
I can hear you.
All right, great. Thank you, Simon. And thanks to Poet for inviting me to be here and to my fabulous panelists. Hard act to follow with all the great work that you guys have going on. Simon asked me to talk a little bit about kind of models for collaboration and to talk about how Maritime Blue does that. We always start with what is the blue economy? Simon gave a little bit of background on that, but for us, it's a broader range of different activities. And it's also really about that triple bottom line value of economic growth, improved livelihoods, resiliency in our communities, equity in our communities, and ocean ecosystem health. We did a lot of work looking globally at different models around blue economy, around different kinds of cluster organizations, different ways of collaborating, doing joint innovation, et cetera, before we came together in Washington State on kind of a three-pronged approach. So first, we worked together to create a strategy for accelerating the blue economy, technology innovation, and sustainability in Washington's maritime industry. This was done through a federal grant through the U.S. Economic Development Administration and for the Washington State Department of Commerce, and with some great match from the Port of Seattle. The Port of Seattle was looking at developing a maritime innovation center. And so we put that into the mix of what we could do. After a year-long process of engaging with 100, 200 plus stakeholders across our maritime sector, our energy sector, bringing in some of our digital and IT sector as well, we released the strategy document in January 2019. And at that time, we launched the Maritime Blue as a cluster organization. Globally, this is a new model that's emerging for how you can increase innovation and economic opportunities. And so Maritime Blue was born as a nonprofit organization with support from the State Department of Commerce and our members. The Maritime Innovation Center, being established at the Port of Seattle, is going through its design process right now. Anticipate the start of construction on that innovation center late next year. It is going to be a renovation of a historic building that is actually going to go beyond LEED all the way to International Living Future Institute standards. So an innovative building, but with the historic upgrade of it being on pylons in the water, it's gonna take some extra time and dollars to make that happen. So the strategy itself has a lot of different components, but I like to talk through this slide, which really is about projects and how we're working to implement the strategy through a focus on projects. So the vision you see there at the end for Washington State to be most sustainable maritime industry by 2050, and the different pathways that we identified to get there. Across the top is essentially our deep decarbonization pathway that talks about ferry electrification. When we started the strategy process, Washington State announced they were going to convert their two largest vessels to hybrid electric. By the time we launched the cluster, they released their long-range strategy that they're going to electrify through hybrid electric operations their entire fleet. So this has created a lot of momentum around the different technologies and providers that are bidding into the process for state ferries, as well as other alternative vessels that can be using battery technologies. And now as we move forward into hydrogen and even other fueling sources. And you see a couple different areas, working waterfronts, the need for really integrated strategic planning processes for our working waterfront, working with the ports on electrification strategies and other things. And then across the bottom was the need for the cluster for collaboration. At this point, Maritime Blue has over 120 members, and those range across what we call the quadruple helix. Those are the industry members, the research institutions from our labs to our universities, our public partners, both local, city, state, regional, federal public partners, our organizational partners that are active in the local communities, as well as national organizations that are focused on things like shipping decarbonization, such as the new Blue Sky Maritime Coalition, And in the middle, the new box we just created is highlighting all of our startups that are being supported through our incubator and accelerator activities. So Maritime Blue has a broad scope of work that we address. At this point, we are now up to 11 full-time employees. We literally just ramped up this year with having a full-time dedicated staff. So we have focus in different areas. I'll talk a bit more about our Blue Forward, our joint innovation projects. That's the area that I lead. We also do entrepreneurial support through founders, where we have startup ventures. Workforce development programs. We have Blue forums that provide knowledge sharing and information. Last week, we were fortunate to work with DNV, PNNL, Department of Energy, David Hume, and MARAD in pulling together a Maritime Electrification Forum. We work on increasing access to capital, both public and private, and hybrid funding models, including foundations, as well as global engagement with other clusters and partnerships that we can do to advance these innovations through even broader collaborations. So just a few words about our Blue founders. This is our focus for entrepreneurship. We have two different programs right now. We have a 4-month mentor-based innovation accelerator that is at the Port of Seattle. Actually, the applications for this are open right now for what we call our third wave or cohort of startup companies that are looking for support. The rendering you see down at the bottom is the Maritime Innovation Center. So once that facility has undergone its renovation, we will actually house our incubator or our accelerator program there at the Port of Seattle. Right now, we do lease facilities at the Port of Seattle, and we actually have our Blue Hub where Maritime Blue is located, as well as several other tenants and startups. We also have a program in Tacoma that just started. It is a 1-year innovation incubator program in partnership with the Port of Tacoma. This one is much more place-based, and it is focused on solving challenges for port operations. So this provides space within the Center for Urban Waters for the staff at Maritime Blue, as well as the startup companies, and they can work right there with the University of Washington and some of the staff that are there working at the Center for Urban Waters. Here's a few examples of some of our startups here, and I'll highlight just a couple success stories. One, Discovery Health Systems launched in our very first cohort of the Seattle-based program to provide virtual telehealth services. Well, they launched right in the middle of COVID, quickly pivoted their business model and developed standards that were actually adopted by the state of Alaska for how to get the fishing industry back to work. And at this point, they're doing testing and vaccinations across the fishing industry, cruise industry, and others, and have ramped up to over 200 employees. Pure Watercraft and Silverback Marine both went through different versions of our programs, but they actually partnered together to develop a brand new fast oil ferry. A joint innovation project really brings together private partners to come together and advance these innovations faster than they would in their silos. So on parallel paths of different scope together at the
So I'm not sure if that's Jennifer or me that's having a technical difficulty.
Am I back?
Hey, Jennifer.
Oh, you're back. Okay, you just faded off for a second.
Okay, well, I will stop my video and try to reshare and see if this works. Let's see.
Is anybody tired of Zoom conferences yet? Can we
Yeah.
all have a happy hour together? It'd be so much more fun.
Okay, well, holler if I start getting unstable or if you can't hear me.
You're good now.
Okay. Well, so I was talking about joint innovation projects that we work on collaboratively on parallel paths to advance these concepts. So with the fast foil ferry, The Gloucester design team and Beaker were working on a new hydrofoil ferry concept. They could have just done this on their own and then come out with the market and seen, if it would get picked up. But instead, we're working collaboratively through a federal grant and the private match of the different partners to advance on several fronts at the same time. So we're working with Kitsap Transit as the transit authority. We're working on the routing analysis of what's the best route to do the first demonstration project. We're working with Tacoma Power, looking at the shoreside infrastructure and what's going to be needed for charging, and as well as advancing the design work itself. And then we're going to continue to bring in partners on how to actually build this vessel, leveraging Washington assets such as our carbon fiber technologies, our different battery technologies, and more. So just as an example, it's a way to work together to advance these innovations faster than you would working in your own silos. Several other programs that we're working on. One I'll highlight is that we are trying to bring forward renewable hydrogen generation at the Port of Tacoma. OCO is a startup commercialization company that has a technology to store hydrogen in the form of formic acid. And PNNL has technology to reform that into hydrogen for a fuel cell. Tacoma Power had a challenge of how do they build shore power for all of their terminals when they're so expensive to build a substation per terminal. So we decided that the use case for this would be a mobile shore power unit on a truck that is provided through the fuel cell. Helps the business case for Tacoma Power, helps advance the technologies for OCO and PNNL, and shows what we can do as a potential liquid hydrogen carrier for future maritime emission reductions through these alternative fuels. So just a couple examples of the things that we're working on in collaboration. Under development, we have a couple different projects. We've been talking with PNNL and many others, including POET, about how we can come together to look at the cost benefit analysis of what's coming for West Coast offshore wind, and looking at that through the lens of the blue economy, the environmental impacts, both pro and con, the economic impacts. How do we capture more of the supply chain and have our ports be ready to really take advantage of the economic opportunities? And how do we engage with our communities in a way that we can actually help capture the benefits for the communities and help move forward with these projects in a way that makes sense for our coastal communities? So that's just in the works of starting to talk about what we can do on that scope. There's several others there, but in light of time, I will stop there and share one more slide on our workforce side of things. Our Youth Maritime Collaborative is really working to connect with communities of color and youth and really expose them to what's the options that are available in the maritime industry. So this is an internship program where we place the interns at our maritime companies. We also provide equity training to our companies to try to help work on job retention. We had several of our interns placed within our startups this summer and have actually heard that those have turned into full-time positions for two of our youth. So excited about this program and trying to spread it beyond Seattle to try to help with this model of building the pipeline of really understanding what the opportunities are in the maritime and ocean workspace. So with that, just want to say that really the key to all of this is collaboration across our sectors, across our silos, our different government agencies, our different aspects of industry, and finding new models of working together to accelerate these innovations, because we really have to move these forward faster than we would in the way we've been doing business traditionally. So just look forward to the discussion and any questions about how we can find more ways to work together. Thanks.
Jennifer, awesome job. And I think your final message about collaborating being sort of the path forward here is a great way to end our presentations. I want to thank all of our presenters. We have only about 5 or so minutes for Q&A, and I have one in the hopper from Richard Ainsworth, who asks about regulatory barriers for marine transport. And maybe I'll try to reframe his question to be a little broader than that. Regulatory process is a fact of life, but as I think all of you discussed in your presentations, we don't always have as much time as we'd like to have, particularly with climate change becoming more and more urgent. And so I'm wondering if, so Richard's question is, do we foresee potential regulatory barriers for marine transport to achieve decarbonization goals quickly? I think the short answer is yes. And the more interesting answer I would like to hear from you is, can collaboration help with that? Can a community-based model help with that? Does having a larger tent to consider ocean-based solutions sort of broadly help with that? Are there ways to sort of help with the regulatory process by understanding the value and getting folks on the same page that might be useful to think about? So maybe I'll pose that to the panel. Looks like Jennifer, you have your hand up.
Yeah. On the kind of the technical side of the regulatory aspects, I'll give one example where collaboration is helping to advance this, and that is on maritime hydrogen safety. DNV has something called a joint development project model, where they bring together the industry, the regulators, which is the key, and other partners to develop the guidebook, which eventually becomes class rules for how to review and approve these new technologies. So this has been a good model on battery hydrogen or on battery safety. The U.S. government MARAD participated in that one, but not the Coast Guard. And for the maritime hydrogen safety, I do not believe that there is any U.S. regulatory participation. So that's an opportunity where we can come together with our regulators, our industry, and the experts, and really talk about what are the key, things they need to know about the technologies to help advance them. But I'll let others speak to the kind of the community engagement side of things, of actually how to help move this forward. Besides engage early and often is the standard. How do we go beyond that? I'd like to hear from the other panelists.
Simon or Katie, I wonder if you have any thoughts about how a community-based or a community-focused model could potentially help find new pathways forward, or new dialogue that could help us move forward more quickly.
Yeah, I mean, and Katie, feel free to chime in here too. I think definitely in terms of like understanding community priorities and kind of what the demand is for some technologies is often important and overlooked versus like the technology push model. And I think, having engagement processes and trying to really work with them hand to hand is one way to overcome that. And I do think it's being recognized as a bigger issue in the renewable energy transition, just writ large, whether you're thinking large scale or more the small scale that we're thinking of, or not small scale, but community scale. I think it's becoming a bigger and bigger recognized challenge. And so as much as I think there's some models that work, I also think there's a lot of things that haven't been essentially tried yet. And so, that's part of our thinking around marine energy and working with remote communities.
That's great. And this is the lightning round. We have 3 minutes. Chris, I'm sort of thinking about, I'm kind of staying on this pace, this speed issue. And, you told a really great story about Sail Drone and about unique sort of models and collaborative partnerships that allowed you to innovate more quickly with industry partners. Can you talk a little bit about that, and maybe from the perspective of a marine energy company, how public-private partnerships could potentially help accelerate the pace of some of this innovation?
Yeah, absolutely. In fact, I was going to ask a question of what people thought of that, because my view is that if there are alignment between, like, for us, it was NOAA and the federal government and what a private company needs. And if there's a shared vision that can be created together, so there's ownership in that shared vision. In this case, the CEO of Sail Drone said, "Hey, I got this vehicle. I don't know anything about sensors. What do you need to measure? How can we help?" And together we came up with things that said, well, we got 20 years of doing it on buoys. We think, absolutely a vehicle could be used in these type of things. And together that shared vision was crafted. It was super powerful in enabling a company to grow from 2 people. They're at 120 now and up to the 3rd round of venture now. And the exciting thing from my point of view is, they were able to hire the best and brightest software development in Silicon Valley. And from our ocean point of view, we turned them into a bunch of oceanographers. We got them passionate about the ocean. They care about the ocean. So they're bringing their unique software skills that they learned at Google, Facebook, Amazon, wherever, and now are applying that to the ocean. And that is only going to create spinoffs and companies once we get people bought into this shared vision. So what do attendees think about that? How has it worked? I'd be interested in equally hearing how it didn't work. Was it an experiment that didn't go so well.
That's great. And we have 1 minute left. Mike, do you want to chime in on that?
Yeah, just quickly. So I think one of the other ways to address this is potentially, public-private partnerships are a tremendous way to do that. Another one is leveraging kind of market forces and getting the private sector to be advocates for what we're driving at. So through the Aspen Institute, we've started a program called COZEV, Coalition for Zero Emission Vehicles, which is an organization comprised of cargo owners who are effectively coming together to present a unified voice and proposal to ship owners, transportation companies, to say, we want to be first actors. We want our cargo moving on zero emission vessels. And the announcement should be coming shortly and up in the next month or so. But they're, some of the biggest companies in the world are participating in this operation. And so they are just taking it upon themselves, because their consumers want it, to demand a transition to zero carbon technology and renewable fuels in the shipping sector. So keep creating this pressure from all the different angles is what ultimately moves policymakers to action. And it is that collaboration that so many others, and Jen's talked about it, and Chris has talked about it, and the community aspects. But creating those collaborations, creating those Big Tent partnerships, are ultimately what policymakers need to see in order to move the needle.
That's great. Dave, I want to give you one shot. Any additional thoughts? I was thinking about green shipping corridors with what Mike was saying there, and the need to collaborate regionally as well.
Yeah, I don't know what else to add other than what's been said already. There's a lot of work to be done out there, and there's not a lot of time to do it, that's for sure. Regarding green shipping corridors, since you brought it up, there is a big potential in trying to establish those. It's a little late in the game to mention this, but the Department of Energy did engage in a collaboration with numerous other international governments called Mission Innovation, which is trying to support the development of 4 fuels of interest, including green methanol, green ammonia, green hydrogen, and advanced biofuels. So trying to support the development of these fuels on some of the major deep sea shipping routes. So we have set ambitious targets by 2030 to help see some of these fuels adopted, but we really need to get going and try and get more demonstration projects out in the world. I'm sure some of you saw the recent announcement by Maersk that they have acquired or will be acquiring 8 e-methanol fueled vessels here in the near future. But we're aiming for about 200 of these ships in the next 5-10 years. So got a lot more work to do.
Great. Thank you all to the panel. You guys did an amazing job. Thanks for our audience. And thank you, Jason, for having us. I see you are here to bid us farewell.
Indeed, Simon. And thank you for bringing together this very, very impressive panel. So exciting to hear these different ideas. Certainly so much to do. David's comments, I think, right on. There's so much to do, and time is not on our side. So I would like to provide some final comments for the day, and we'll be shutting down after that, and we're looking forward to you joining us tomorrow. So I hope that you got as much as I did out of these 4 panels today. I'd like to close just a few comments and reminders. First of all, I want to thank today's presenters. I hope everyone recognizes how fortunate we are to have such an impressive lineup today. I also want to observe that the scope and complexity of the issues that we need to address as a society, I think, require our best and brightest. And I think we heard from some of those folks today. As we heard from Rebecca and Shannon's opening panels, it's clear that we are living through literally an energy system revolution. We're going to rebuild our entire system over the next 30 years. I, for one, intend to live to at least 2050 because I want to see that play out. But the path forward at this point is pretty hazy. And I think it behooves us all to remember that how we engage and what we do on a daily basis truly matters to where that path will ultimately lead. It's also clear that as we rebuild our energy systems, we have to understand that it's about more than just electrons. Not only must we work with our communities, but we also need to deeply integrate environmental justice and equity matters into our new systems. That's an uphill battle in large part because of the inertia of the older systems. But we'll need to be thoughtful and diligent to ensure our values are integrated into the energy systems of the future. And as we saw with Simon's final panel, there are some truly exciting opportunities for all of us to engage. I was struck by the array of important efforts that we heard about today. And of course, that was not an exhaustive list of the issues or the opportunities. So there is truly so much to do. We've heard a little bit about it today. So that concludes today's event. Thank you again for participating. I hope you enjoyed it. Please reach out to the POET team with your thoughts and feedback. It's important for us as we try to improve our future events. And hopefully tomorrow goes about as smooth as today went, even with these new technologies. So I'll remind you that we start again tomorrow at 9 a.m. Pacific time. And if you happen to be in Portland, please consider joining us tomorrow evening at around 4:30 at the White Eagle. Hopefully the weather will cooperate and we can sit outside and enjoy some nice Oregon fall weather. Oh, by the way, happy first day of fall. I believe that is today. So hopefully we'll see you all tomorrow in person at the White Eagle. And with that, that concludes day one of the Ocean Renewable Energy Conference. Thank you all again. I look forward to seeing you again tomorrow.